Let us do a little bit of recap of what we have done yesterday for rate of change. Alright, Brazil, can you remember what you understand by the word rate? What is being involved? Speed, but there was a more precise term that we were using. Time itself, thank you. Anything connected to rate, you must know that time is involved. If time is involved, how do we represent it in this case? Mathematically? Yes. dt. You need to differentiate the unknown variable with respect to t, which is your dt. You need to differentiate the unknown variable with respect to t. Alright? Today I'm going to bring in something new called the chain rule. Okay, the use of the chain rule is such that you are making use of two rates of change to find whatever unknown that you need to find. Okay, you are going to make use of two rates of change. Alright, I'm just going to write it down first. In this case, if the two variables I'm concerned with, it's just dy over dx. If the two variables is y and x, if I want to involve my rate of change, this is what I'm going to do. The equal sign is in front, the multiply sign is behind. What is in front is the rate of change of y, which is the one for the numerator. And the good guess is the one at the denominator will be behind, the rate of change of x. And you realize that this equation works. This whole thing is called the chain rule. Okay, this is the chain rule which we are going to make use of in our work problem today. Okay? Okay, I can give you another illustration. It need not always be in terms of dy dx. Let's say now I have another one. dA over dr. Likewise, if it's dA over dr, can you tell me what are the two unknown variables here? A as well as R. So what will be the connected rate of change in front over here? You look at the numerator or denominator. Numerator. So what will you write down here? The rate of change of A. So it will be dA over dt. Multiplied by what will be behind? Okay, behind will be the rate of change of R itself. Okay, this is the chain rule itself. Okay, but no use memorizing this. This must be applied into a work problem itself. Then you'll be asking, what kind of work problem can it be? Because the work problem we deal with yesterday were all pretty straightforward. Okay, today we're going to see something a little bit more interesting. Okay, you could actually do it in your physics in the lab if you want to, but it's going to take a bit of time. Page 359. Can you take a look at practice now 13? Just read the question yourself first. I know many of you all will not be able to get started because you don't really know what you need to do. Okay, let us read sentence by sentence. The radius of a sphere increases at the rate of 0.1 cm per second. What is the rate of change we are looking at? Is it the sphere or is it the radius? It's the radius of the sphere. So, since the radius is the variable we are looking at and the rate of change is for the radius, I'll write down dr over dt. Please write it down first. 0.1 cm per second. This is the rate of change of the radius. Then it's nothing already. What are we going to do? Now let's take a look at part A. Okay, what is part A trying to tell us? Find, or rather calculate the rate of increase of the surface area. If it's the rate of increase of surface area, are we concerned with the area itself? All agree? Area will denote by A. Normally it's capital A. Try not to use small a. Since it's the rate of change of the area, this is what we are supposed to calculate. All agree? Okay. This is given, this is given. There must be a third one given. Remember, we need to make use of the chain rule. Now, look at the question again. Surface area of what figure? What is the surface area we are looking at? What kind of figure? Sphere. What is the formula for finding the surface area of a sphere? That is E math. 4 pi R squared. Thank you. This is a function for finding the area of a sphere. Alright? Take note, there will always be 3. The third one is a formula, or rather a function you have to come up yourself if it's not given. Now, this is in terms, the subject is A, the variable is R. Am I able to differentiate this particular function? You mean? How to differentiate this function? How do you write? dA over, what is the variable over here? R. So it must be over dr. So if I want to differentiate over here, what do you get? Thank you, we are done. Do we have 3 connected rate of change and variable? Let's take a look again. Take note, the one in the middle will always be the one that has no rate of change. You realize? So if I take a look at these 3, which is the one that will be in the middle for that particular chain rule that I'm using? Will it be dr dt? No. Will it be dA dt? No. What will it be? dA dr. So let's put that in the middle first. dA over dr. Equal in front, multiply behind. Alright? What will be the one in front over here? Eating. dA over dt. Thank you. Viviana, what will be the one behind over here? No, there cannot be any. Take note, the one for the numerator, the rate of change will be for A, so it will be in front. The one behind will be the rate of change for, the one behind will be the one for the denominator, so it will be the rate of change for the radius. Now, take a look. Now, this function, actually, is it applicable for the chain rule? If you notice, I reduce the over term, the dr and dr can cancel. All agree? Then you become dA dt. Okay, of course you can't do the cancellation. Okay, but this is what we call about the chain rule. Now, plug in everything. dA over dt. Do we have the value? Don't have. In fact, we are supposed to find. Equal. What is dA over dr? What is dA over dr? It's dA dr is over here. Agree? Multiply by dr over dt. What is dr over dt? It's already up here. But now, they say find the rate of increase of the surface area when radius is equal to 12. Giving each of your answer in terms of pi. So we do not press the calculator function for pi. So just replace your r, which is the radius, by 12. Now, press the calculator and simplify everything. If I'm not wrong, 9.6 pi. Now make a very good guess. What will be the units of measurement? Just now, the radius with respect to t, or rather the rate of change of r, is 0.1 cm per second. what will be the rate of change of the area? cm square per second. And there you have the rate of change of the area when the radius is increasing by 0.1 cm per second.